Hey guys, welcome back. Today we're going to run a back test to try to identify which stocks have the potential to rise more than the index or benchmark from a current drawdown. In this tutorial, I'm going to back test the Qs since I believe that the technology sector has been beaten down more than other ETFs or indices. So within this ETF, I'm going to extract the returns for the constituents, and inside the basket of stocks, we're going to calculate upside beta and downside beta to see which of these stocks rise more than the index on positive days, and also which stocks decline less when the benchmark declines. My first thought was that stocks that decline less than the benchmark on down days and rise more than the benchmark on positive days should outperform, but we're going to take a look at the returns because that's not necessarily the case. So here I'm going to require some packages. We're going to source a function that grabs constituents for ETFs, and I'll post a link down in the description area of where you can find this function. I'm going to load these packages and source those functions. I'm going to assign my ETF to the Qs. I'm going to grab the constituents, extract the symbols or tickers from this ETF. We're going to grab historical data from Yahoo Finance for each of these stocks, including the ETF. So I'm going to create a new environment called E. I'm going to use get symbols from QuantMod for each of the tickers and store all the data in that new environment from 2018. So I'll go ahead and run that. After that's done running, I'm going to merge all my data into a single XTS object by running do call merge. So I'm going to merge all the adjusted closes, and I'm also going to run NALOCF to handle any missing values. After we merge all of our adjusted closes, I'm going to run ROC to calculate daily returns. And for any NAs, I'm going to insert a 0. To get rid of the dot adjusted in the column names, I'm going to run gsub to replace those instances with empty spaces. So I'll go ahead and run that block. Next, I'm going to be extracting the top 10 worst drawdowns for the Qs and store it into DD. So we'll go ahead and run that and take a look at that table. Now, by using this table, I'm going to extract the dates for the second worst drawdown, since this first drawdown is the one we're currently in. And to be more specific, I'm going to be testing and extracting betas by using the from date and trough date to see how the constituents performed during this time period. So we're going to go ahead and select row number 2 for the dates. So here back in our script, I'm going to assign 2 for n. So I'll run that. And in this function, we're going to pass each constituent or stock. And within this function, I'm only going to focus on those date ranges for the second worst drawdown. I will then use cap and beta bull and cap and beta bear to extract upside beta and downside beta. So that'll give me the betas for this date range, and then I want to test how the stock performs 6 months later. If you want to return something other than 6 months, you would change line 33. For each of the constituents, not only are we returning the betas, but also the returns 6 months later to see how the stock performed. And I'm going to be returning everything as a data frame, which includes the ticker name, the downside and upside betas, and the out of sample return for those 6 months. So let's run this block. I'm going to return that as a data frame and also change the column classes to numeric by running lines 42 through 44. So we'll run that block. We'll take a look at our table. We have 98 entries, and for each of the stocks, we get the downside beta, upside beta, and out of sample return. Now, by using this table, I'm going to split those stocks that have a higher upside beta than a downside beta and create a separate object for those stocks that have a greater downside beta than an upside beta. And we're going to take a look at the returns. So we'll go ahead and close this out. If we scroll up here, we'll go ahead and run this block, and we'll take a look at the console. Alright, so overall, after we hit the trough, the average return for all the stocks was approximately 45%. If we only invested in those stocks that have a higher upside beta than a downside beta, our returns would have been slightly lower at 40%. But if we would have invested in those stocks with a higher downside beta than upside beta, our returns would have been better than the average at 53%. And I think this is because we would have invested in those stocks that got beaten down more than the index or the average. And when the index rose, those stocks that got beaten up the most rose more on average. Now let's see if that's the case for the current drawdown. So I'm going to minimize the console, and we're going to take a look at that first drawdown. Everything else stays exactly the same. I just copied it from the code above, but instead of using n as 2, we're going to use n as 1 to return the first drawdown. So let's go ahead and run this block and check out the returns out in the console. And we'll take a look at the dates in a second, but the average was approximately 9% for all stocks. If you would have invested solely on those stocks with a higher upside beta than a downside beta, we would have done slightly better. And if we would have invested in those stocks with a higher downside beta than upside beta, then our returns would have been about 6%. And it does make sense because you don't normally want to be invested in stocks that decline more than the index or benchmark when it's having a terrible year. And if we take a look at our drawdown table, it's using 11.3 as the trough. So we're not really sure if that's the final bottom. But this concludes the video, guys. I hope this was useful information. I will leave a link down in the description area to my Patreon where you can find the script. Please subscribe to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.